411. My name is Emmy Pallenbaum. I am the Extension Assistant with the South Carolina Sea Grant Consortium. I'll be one of the moderators for this session, along with Brooke Sari, who is the Coastal Environmental Quality Program Specialist at the consortium as well. Thank you so much for coming to the series. As a recap, this is a 4-part webinar series to address flooding issues that we experience as coastal residents of South Carolina. Each of these 4 sessions will have presentations from scientific, government, and education experts to help you understand causes and types of flooding, the role different agencies play, as well as protection and safety measures from flooding and more. So we're really glad to have you all with us today. And for our first session will be Water in Our Landscape, Constant Change. For this session specifically, we will talk about give you a background knowledge on the hydrology in coastal South Carolina, exactly how water moves across our low country landscape. And we'll also learn to distinguish between the different types of flooding that occur in our region and sources of flooding, as well as give you an overview of an assortment of online tools and resources to reference back to learn more about flooding and gain more information in the future. I'm joined by 3 speakers today and our hosts. So with that, we will go ahead and get started. Just for some overview basics for today's session, please keep your cameras off and your microphones muted throughout the session. And if you're having difficulty with bandwidth, be sure to close other programs and tabs to help with that. If you do run into issues, feel free to exit the session and rejoin. And during today's session, you are more than welcome and encouraged to ask questions. Please utilize the Q&A box at the bottom of your screen, and we will have time for questions after each speaker, as well as at the close of the session. If you're unfamiliar with where the Q&A box is, it should look like this at the bottom of your screen in the lower panel. You can also adjust your audio settings if you're having any trouble today. And then on the right-hand side is where you can leave the session and rejoin if needed. So as I said, this is part of a 4-part series, and you can learn more about the series as well as our previous Ask an Expert series and other information on our website up there in the left top hand corner, which I will put in the chat shortly. All of these sessions will be recorded and will be found on this website at a later time. So be sure to revisit those if you're not able to join us for the other sessions. And if you'd like to learn more information, you can also visit the Flooding 411 YouTube channel or contact our team with any questions using that Gmail account in the bottom right-hand corner. Our 3 speakers today, I am really excited to introduce Brooke Swartacki from the South Carolina Department of Natural Resources, as well as Katie Finnegan with the South Carolina Sea Grant Consortium and Jeff Doberf with the National Weather Service Southeast River Forecast Center. So to kick it off, I will hand it over to Brooke Swartacki, who is currently a coastal hydrologist with the South Carolina Department of Natural Resources and has been with DNR since 2014. Her work is largely focused on the coastal plain aquifer system, and she helps to manage a statewide groundwater monitoring network. And she also studies saltwater intrusion into groundwater. She assists with the state's river basin planning efforts, and she also holds a master's degree from the College of Charleston's Masters of Environmental Studies program. So with that, I will go ahead and unshare my screen so that Brooke can share her presentation.
How does that look?
Looks good.
That looks
Okay.
good.
Thank you very much for that introduction, Emmy. I appreciate it. Today I'm going to talk to you guys a little bit about how water moves in our state. So as an overview, I'm going to talk about the water cycle, a water budget for South Carolina and in different areas of South Carolina, the functions of floodplains, and how human activity alters that water budget. I think most people are familiar with the water cycle, but I like to start here with this image from the USGS because I really think it shows how water is in constant motion, and it is in a perpetual stream that shifts from compartment to compartment. The sun is driving this process, and our largest compartment of water would be the ocean. So the sun radiation causes the water to evaporate into vapor. Also, the sun's driving process called evapotranspiration from the land, where water is being transpired from the soil and leaves. This water vapor is condensed in the atmosphere as clouds, and then the clouds release the water as rain or as precipitation that falls directly into water bodies, or it falls onto the soil where it can infiltrate into the ground as groundwater. This runoff into the soil, which is infiltrated, eventually reaches our deep aquifers, which are rocks capable of storing vast amounts of water. And then eventually that is discharged to the ocean via groundwater or freshwater lakes, rivers, and the cycle is hence preserved. So if this water is in different compartments and it can move from compartment to compartment, we could quantify it and enumerate it with a water budget. A water budget is just a simple and universal equation of water movement and storage. It's basically a system of checks and balances and ins and outs that can tell you if a system's balanced, if it's losing water, or if it's gaining water. And the water budget can be scaled to statewide, like this figure here on the right, or it can be scaled to smaller watersheds. So the image on the right is a water budget for the state of South Carolina. Here we've got inputs of precipitation and stream flow from North Carolina, and then outputs of evapotranspiration, stream flow into the ocean, and aquifer discharge to the ocean. This conceptual water budget here is balanced, but it's not always balanced. We know that the state of South Carolina isn't just a green flat figure on a piece of paper. It's a very large, diverse state. It's defined by physical geography and geology. This map here shows is watersheds and rivers in South Carolina, and but I want you to pay attention to the top, the middle, and the lower portion. We have three main physiographic provinces in South Carolina: the Blue Ridge, the Piedmont, and the Coastal Plain. The Blue Ridge and the Piedmont provinces, up to the upper left, are composed of metamorphic rock, and they break between one another on the basis of topography, which is about 1,000 feet in elevation. And then at the Piedmont and the Coastal Plain, those are broken apart by the fall line, which is the contact between the metamorphic rocks of the Piedmont and the unconsolidated sediments of the Coastal Plain. One of the things that is prominent in the Coastal Plain, not shown on this map, is a vast aquifer system. So because we enjoy a mild climate, we have a mild climate due to our proximity to the ocean and our proximity to the Appalachian Mountains. Our average annual statewide precipitation is varied across the state, with the highest amounts of precipitation in the Blue Ridge region, intermediate amounts near the Coastal Plain, and the drier regions in the Piedmont. The average annual temperature is about in the mid-60s, and most of our water comes from precipitation. It ends up in lakes and rivers, which, as I said, are very visible on this map. We have, in fact, over 30,000 miles of rivers and streams that drain South Carolina. And in this small inset map down here towards the bottom, broken up into 4 larger watersheds, you can see that we're also gaining water from our adjacent states, Georgia, North Carolina, and even a small portion of North Carolina and of Virginia. Given that these environments are very diverse, I've chosen 3 pictures up here, a mountainous and a picture of the sandhills, and then a picture at the coast. That water moves very differently in here. In the Blue Ridge and the Piedmont, topography is really important because these large rivers are the headwaters for our systems that eventually reach the coast, which carry water and sediment. And then the rolling midlands just below the fall line are very important areas for groundwater recharge. There's very high sand in these soils, and it allows for infiltration into our deep aquifer system, which supports human use. And then moving towards the coast, the topography really flattens out, and then broad meandering waterways and floodplains allow for agricultural use. And much of the development is centered towards the coast. And then when we get to the coast, instead of having a unidirectional flow from the rivers towards the coast, we begin to have tidal influence. And so the hydrology becomes bidirectional, where we're having interaction with the ocean, and much of the land in the outer coastal plain is tidal. All of that water eventually discharges into the Atlantic Ocean. So what happens on the land in a watershed affects the water quality and the quantity. A watershed, which was shown on that map before in those colored blocks, is any land area drained by a common river system where all of the streams flow to a common outlet. But besides the river itself, the most recognizable feature in a watershed is likely a floodplain. And floodplains is a low, flat land along a stream channel that's periodically flooded with water and sediment. They're usually bounded by a terrace on either side, and they offer and convey numerous benefits to this ecosystem. So I'm going to describe some of the floodplain benefits. They're very important for slowing down water. So they're important for the storage and conveyance of floodwaters. Some of their chief benefits to the ecosystem would be to protect water quality, preserve the local ecosystem, reduce the severity and frequency of floods, and to recharge our groundwater reserves. This picture here on the right is of the Congaree River, and you can see this is in the upper coastal plain, but it's meandering across the landscape, having a lot of contact with the land. So you can imagine that many of the floodplain benefits are being felt in the ecosystem here. Speaking of groundwater, because groundwater is my scientific specialty, many think that groundwater and surface water systems are disconnected, but in fact, they're not. Our groundwater systems are connected to rivers through floodplains. This picture over here on the left is a picture of a swamp, and we can think of this area as a groundwater recharge area where these rivers and streams interact with the water table. The cartoon on the right kind of shows a slice of a conceptual groundwater system where we have the water table separating the soil zone, which is the unsaturated zone of the earth, with the saturated zone underneath the water table. During times of precipitation, it infiltrates down through the unsaturated zone to the water table. And then if it's given time, deep aquifer recharge can happen. The water table moves in response to precipitation, it moves in response to evapotranspiration. So at different times of the year, there'll be more aquifer recharge than other times. And then so if we think about this in the water cycle, that this water that is being banked into the earth can be support stream flows, especially during times of low precipitation. Base flows of streams is particularly important when we enter the terminus of rivers as they enter estuaries. So that's because the freshwater inputs are very important to support ecosystem functions and maintain habitat and provide nutrients for downstream communities. Okay, so I told you a little bit about how water moves in the landscape, but what happens when that water cycle and that natural flow is altered? Flooding is closely associated with the fact that humans decided to build their settlements in floodplains. They built their settlements in floodplains because there was access of water to use for commerce and for transportation, and floodplains had fertile land for them to grow their crops. So because I live at the coast, I've got a coastal view of looking at flooding. And 27% of the South Carolina population lives at the coast because we enjoy our beaches and we enjoy our livelihoods from the water. And so more and more people are moving to the coast. But with more and more people moving to the coast, we're seeing more and more floodplain development. I just chose to show a couple pictures of flooding that has occurred in recent years from hurricanes and from a king tide in Charleston, just to illustrate that flooding in a floodplain associated with development. And I'm going to use the Charleston Peninsula as a case study. If you live in Charleston, you've probably experienced flooding. On the left here, I have a plan of Charleston from 1849, and on the right, I have current day Charleston. So two things that you can notice by looking at these maps is that the shape of the peninsula is very different. In the plat, you see that there was good connectivity to the harbor and stream courses coming into the peninsula. And then on the right side, we see that we've built out the peninsula and highly developed it. It used to be accustomed to daily pulses from tides. Large range events happened, storm surge happened, but recently flooding has become worse and worse due to several reasons. And the geology and the geography of the Charleston Peninsula can help illustrate why. So the western edge of the Charleston Peninsula was formerly marshland. And now we see that that is where the hospital complex and the Joe Riley Stadium is. So if you have lived in Charleston, you've probably experienced flooding in these two areas. What they did was they came in, put artificial fill in, and then built up. Now, this interrupted the connectivity to the harbor, and but the tide doesn't care, and so it still comes in, and then we experience flooding. Chiefly, the reason why we are having this flooding is because we've added more impervious surface. So this development that has happened has removed the trees that were primarily responsible for evapotranspiration, and have removed the land that allowed for infiltration. So less water is retained in the system, and this creates more runoff. Well, in the case of coastal, more runoff means more flooding. And on the Charleston Peninsula and other areas in the coastal zone, precipitation plus excess runoff plus high tide is a triple threat for flooding. The water literally has nowhere to go until the tide goes out. So I'm going to stop right here, and I'm going to let my colleague pick up with more about a detailed look at coastal flooding. So to summarize, I talked to you about how water is in constant motion through the water cycle. The water budget in South Carolina is dependent upon location, our climate, and our geology. Floodplains chiefly store water and reduce the severity of floods, but we have altered that water budget and the functions that floodplains can provide by our development. Thank you very much. If anybody has any questions, I'm happy to entertain them.
Thank you so much, Brooke. So if there are any questions, please put them in the Q&A box specifically for Brooke, or we will go ahead and move on and we will pick them back up at the end of the presentations. I don't see any right now, Brooke, so.
Thank you.
All right. Actually, I mean, we just got one in, so Brooke, you're not off the hook yet.
Okay.
Oh, I see it now. Okay, so someone would like to know what the meaning of the 100-year flood is.
100-year flood, that it's actually a misnomer. We didn't have a 100-year flood. We had a 100-year rain event, and it is a recurrence interval for how often we would expect to see a flood. So with a 100-year flood, we would expect to see that 1 out of 100 years. So a 1% chance of that happening every year.
Thank you. I see.
If any of our other experts want to weigh in on that, because that was a bit of a maybe of an elementary definition of that.
We did have one more question come in. Is there a change in water runoff in elevated homes versus slab on grade?
I'm going to have to defer to someone else for that question. I don't know the answer to that.
I wouldn't say that there's a change in runoff. I'm not sure if maybe this question is hinting at the amount of impervious surface that's maybe associated. I think how I would kind of answer that is if your home is elevated, obviously there's greater opportunity for you to not be flooded when certain events happen versus if you're on the ground. That's kind of how I would address that. I hope that kind of gets at the root of the question.
Thanks, Katie. So I don't see any other questions right now, so we will go ahead and move on to our next speaker, and I'll hand it over to our other Brooke to take over.
Hi, everybody. I'm Brooke Sari with South Carolina Sea Grant Consortium, and I'll be your moderator for the next 2 talks. And thank you, Brooke, for that wonderful presentation. So our next speaker is Katie Finnegan, my colleague. She is the Coastal Processes Specialist with South Carolina Sea Grant Consortium, and she's located at Coastal Carolina University. She's a professional engineer with 7 years experience in designing water resources and coastal engineering projects. Her presentation today is Understanding Types of Flooding, Current and Future. And so your presentation looks good, and I'm going to turn it over to you, Katie. Oh, it just disappeared. Oh, I know what happened.
Are we good?
Yep, you're good.
Okay. All right. Thanks, Brooke. And as Brooke Swartacki mentioned, I'm kind of going to focus more on the coastal impacts that we see with flooding, and also how climate change can impact some of those effects that we're seeing. So a little bit more about how I'm going to get into that. I'm going to start with a review of some of the extreme weather events that have impacted South Carolina since 2015. I'll make sure that I cover the various types and causes of flooding that we're seeing in our coastal environment. And also make sure to review sea level rise and tidal flooding, again, some concepts that Brooke started to introduce in her talk. We'll look at some changes in rainfall, and then also kind of what all this means for our future. So just throughout the presentation, I want to give a background. I'm going to be referring to a couple of different water level gauges or tide gauges. These are either found through the National Weather Service or through the National Oceanic and Atmospheric Administration. Both of those links are down there in the corner on the slide, and maybe Emmy or Brooke can put those in the chat if you're interested in looking at them. But the 3 I'm going to refer to kind of to get a coverage of coastal South Carolina, because I know people are from various places in South Carolina. In the north, we have the Spring-Made Pier. That's a good indicator for what's happening in the Myrtle Beach area. In Charleston, we have one located on the Cooper River in the Charleston Harbor. And then for those down in the Beaufort and Hilton Head area, there's a gauge at Fort Pulaski right there on the Savannah River with the border of Georgia. So I'll refer to these gauges and what various water levels were associated when I'm looking at the history of our storms. So to start off, in 2015, we had a combination of weather conditions, including Hurricane Joaquin, and it was offshore, essentially directing a fire hose of rain at South Carolina, and this led to record rains throughout much of the state. And I realize you probably can't read the scale on that precipitation figure in the corner, but the dark purple color you see is 20 inches or greater, and the red is 1 foot. So this rain event that we experienced coincided with a king tide, which I will define a little bit later. And that persistent onshore winds led to major tidal flooding throughout much of the Carolina coast. So if we're thinking about those water level gauges that I just introduced at the Spring-Made Pier, this flooding event was the 16th highest water level recorded at that location. If we look at the Charleston one, it was the 13th highest water level recorded at that location. And then if we go down to Fort Pulaski, the event actually didn't make the top 20 because you can kind of see in that figure that the Beaufort area is in a green color, meaning they only got like maybe 2 inches of rain from this event. So just so you can get an idea of how rain events can affect different parts of the coast. And just for your comparison, as we kind of talk about things, for the Spring-Made Pier in Myrtle Beach and the Charleston gauge, the #1 event for the water level recorded is associated with Hurricane Hugo in 1989. So just so you have a scale of reference there. And I'll talk about the #1 water level for the Fort Pulaski gauge next, which was Hurricane Matthew. So the following year, South Carolina, we had Hurricane Matthew. The storm luckily hit at low tide, which was very fortunate. However, if we're looking at the Spring-Made Pier, the water level recorded there was the second highest on record. For Charleston, it was the 4th highest water level on record. And as I mentioned, for Fort Pulaski, this was the highest water level recorded at that location. The picture that I'm showing there, in case you're wondering, is in Horry County. So then in 2017, we had Hurricane Irma. If you're looking at the path down there in the corner, it was a very large storm, about 400 miles away from South Carolina. You can see it mainly impacting Florida, Georgia, and Alabama, but its size still brought major flooding, especially to the low country area of South Carolina down in Beaufort. That gauge at Fort Pulaski recorded the 2nd highest water level on record behind Hurricane Matthew. And that was associated with Irma. Then Florence came ashore in Wilmington, North Carolina, and much of the effects came from how it was a very slow-moving hurricane. It brought 23 inches of rain over 4 days. This made the hurricane unique in that a lot of the flooding came down through the river system, as opposed to maybe more of the oceanfront impacts that we typically associate with hurricanes. This is another picture of flooding in Horry County. I know so far I've kind of only mentioned the 3 water level gauges at the coast. But through that National Weather Service website, you are able to see a broader network of gauges that cover the rivers throughout the state. And Jeff, our last speaker, is going to talk more about those. But if you were to look at any of those river gauges, especially in Horry County, on like, for example, the Waccamaw River, you would see that they recorded their highest water levels as a result of Hurricane Florence. So then Isaias, it spared Charleston and the Low Country for the most part, but it did make landfall across the North Carolina border in Ocean Isle, so it really had an impact to the Grand Strand. The picture I'm showing is a part of the pier in Cherry Grove up in North Myrtle Beach. I show this picture because it's kind of interesting. If you look closely at the background of the photo, you see, these men are working, but behind it, we still have people with their umbrellas up, their beach towels out, they're in their swimsuits. They're enjoying their day at the beach. And honestly, this is just a picture of the reality that we live in. Hurricanes come, they cause this destruction, but we have to recover. People live here, people come here to vacation. It's just a part of the cycle of getting things back up and running. And then Hurricane Isaias, if we're looking at the Spring-Made Pier water level gauge, it was the 3rd highest on record. So I think we're all aware that the official start of hurricane season was last week on June 1st, and we will be in hurricane season until November 30th. Every year, NOAA announces their predictions for the hurricane season. So I want to take a minute to review their 2022 predictions. They are predicting an above average hurricane season. This will be the 7th consecutive year that they are predicting an above average hurricane season. So what they're anticipating are 14 to 21 named storms. This qualifies as anything that has winds of greater than 39 miles per hour and higher. Of those named storms, they expect 6 to 10 of them to become hurricanes. And the definition of a hurricane would be winds of 74 miles per hour and higher. And then of those 6 to 10 hurricanes, they expect 3 to 6 of them to fall under the major hurricane status category. This would be a category 3, 4, or 5 hurricane with winds of 111 miles per hour or greater. So this increased activity in the hurricane season is attributed to several factors, including that we are in an ongoing La Nina pattern. So we have warmer than average surface sea temperatures in the Atlantic Ocean. Further, this is enhanced by a West African monsoon, which is supporting African easterly waves, which have historically produced some of our strongest and longest lived hurricanes that we've seen in previous seasons, like Hurricane Sandy. So now that we have a little glimpse of our recent history, I want to just review some different sources of flooding starting from the sea. So we'll talk about high tide flooding, our storm surge, and our sea level rise. So tides are caused by the gravitational pull of the moon and the sun. The moon's gravitational pull generates something called the tidal force. And then this tidal force causes Earth and its water to bulge out on the side closest to the moon and the side farthest from the moon. These bulges of water are high tides. And then on the opposite sides of the Earth, we're experiencing the low tides. In South Carolina, and in fact, all of the East Coast, we experience semi-diurnal tides, meaning there are 2 high tides and 2 low tides every day. So tidal flooding can occur during these high tides, especially when it's a full or a new moon. And especially when a full or new moon and the sun align. And this is what we call our spring tides or extra high tides. If we take that spring tide, which is occurring on a full or new moon, and then we combine it with an offshore weather system, either winds or some kind of storm or change in atmospheric pressure, we will experience what's called a king tide. And as Brooke mentioned, we had some of those in November of last year. You might even remember more recently in May, when we had the total lunar eclipse a couple weeks ago, that there was some king tide flooding experienced in some areas of our coast. I do just want to plug a website here, and it's also an app. It's called My Coast. So this website is supported by the South Carolina Department of Health and Environmental Control. And one of the features on it is a focus on king tides. So you'll be able to see there, they have a list of the 2022 predicted king tides. If you sign up, you can get an email notification or a notification on your phone ahead of these king tide events. And one of the neat things about this app and website is you can help submit your king tide reports. So I'm showing an example of that on the screen from one of the users. So if you have this app on your phone, you can just take a picture whenever you see flooding, and then it will use the time and location on your phone and correlate it to the nearest water level gauge. In this case, it was the Spring-Made Pier, to kind of show what was happening at that time. Whether you choose to submit photos or not, on this website or on the app, you can see what others have submitted. So if you're curious about what's happening in your area, you can see all kinds of things that have been submitted across South Carolina. My Coast does have a few other features besides king tides. I'll let you kind of explore that on your own. But My Coast is also used in several states across the country, both on the East, West, and Gulf Coast. So if you have if you're curious about what's happening in other places with king tides, or maybe you have family and friends and you want to share this resource with them so they can also use it and contribute. So in our discussion of hurricanes and flooding so far, we've talked about the height of the tide, but there's also an important factor called storm surge. And this explains how wind influences the water levels we experience. The storm surge is the height of the water level above the normal predicted tide, and it does not include waves. So storm surge is produced by water being pushed towards the shore from the cyclonic winds of the hurricane. The storm surge that we experience depends on a number of factors, including the storm's size, speed, its intensity, and the angle in which it's approaching the shore. The characteristics of the continental shelf are also going to play a factor in the storm surge. I'm going to show a video here that goes through 2 examples of if we have a shallow continental shelf or if we have a steep continental shelf. Before I play the video though, I do want to say like, be mindful of the scale of this video, because as you can kind of see, it might look like we're just talking about the beach slope or the shore face, like what's happening directly offshore, but this is meant to represent the shallow continental shelf. The beach slope is important. It does influence where waves are breaking, but what I'm trying to demonstrate here is the amount of surge that can be brought to shore based on the winds. So I'm going to press play and hopefully this comes across. So if a Category 4 hurricane hits an area like Louisiana, which has a very wide and shallow continental shelf, you could experience up to 20 feet of surge. You can see that it's pretty quickly going to take out this house. And then, however, if we look at a different scenario with a steeper continental shelf, same Category 4 hurricane, this would be an example for like Miami, Florida. The surge is not going to get as high, probably only like 8 or 9 feet, not going to be necessarily taking out the house as quickly. So you might be wondering, well, where does South Carolina fall in terms of our continental shelf? Hopefully you can kind of see that image in the corner. We definitely don't have anywhere near the same steepness as Miami, but we also don't have the same width that Louisiana does. With our continental shelf, we're more like Louisiana in the ability to have higher storm surges. You can see some features. I'm not going to go too much into the geology background, but there's some ridges and escarpment and some bumps that kind of play into the continental shelf off of South Carolina that affect the surges that we can experience. So how does the tide affect groundwater? So as the ground becomes saturated with salt water, it expands up. So this pushes fresh water closer to the surface. So you're going to see more flooding of low-lying areas. It also means that during a storm event, water won't drain into the ground as quickly because there's nowhere for it to go because the groundwater table has been pushed up. To kind of look at the history of tidal flooding, so this is a graph of flood days recorded at the Charleston Harbor. It goes back to 1922. In this scenario, a day of flooding is counted as if that water level gauge that I talked about reaches an elevation of 7 feet. So just so you have that for reference in your mind. I'm going to kind of focus on the recent history in this graph, kind of to align with that storm narrative I gave at the beginning. So I have 2015 and 2016 highlighted in green. 2015, there were 58 days, and 2016, there were 55 days of flooding. Again, that's assuming that, or that's times when the water level gauge hit 7 feet in elevation. Then we kind of see a drop off in 2017 and 2018. And then in red in 2019, we hit our record of 89 days of flooding. And in 2020, 68 days of flooding, both higher than the previous 2015 and 2016. Last year, it was lower at 46 days of flooding. I want to show that we can observe a similar trend at Fort Pulaski. So at this station, a flood day is counted if the water level measured 9.5 feet. And I just want to point out that this threshold is different than the Charleston one because these flooding elevations are specifically tied to the location. However, again, if we look at 2015 and 2016 in green, we see high flood days in comparison to recent history of 27 days each. We see it kind of drop back down in 2017 and 2018. And then again in the red with 2019, we had a record of 42 days, and then 2020, 38 days, and then 2021 dropping back down to 21. So we're kind of seeing this pattern of like some spurts, then it goes back down, and then it jumps back up. This might not be exactly what we expect. You know, we want like a linear trend or an exponential trend. We want a line to be followed, but ultimately we're dealing with Mother Nature and she's not always going to follow a smooth line on a graph. So what could be causing this increase that we're seeing in tidal flooding days? One thing is sea level. There are multiple factors that cause sea level to change, and I do say change because sea level is always relative. Some places it can be lowering, while other areas it can be increasing due to any number of factors. For example, when water warms, it becomes less dense and therefore it takes up more space. If we see circulation patterns in the ocean change, that can cause water to pile up on one side of the ocean. For example, El Nino years, they usually have a higher sea level on the East Coast due to a persistent high pressure system over the Gulf of Maine that's causing the water to pile up. Ice melting off of glaciers adds fresh water into the ocean, and then land can move up and down either from groundwater being withdrawn or being added to, or even seismic activity. So for Myrtle Beach, if we want to look at sea level rise trends, it's risen about 1.6 inches per decade, kind of looking at the historical timeline that we have available to us. And in Charleston, it's risen about 1.3 inches per decade. These are both about double the global average of sea level change being it rising 0.7 inches per decade. One of the largest influences to rising sea levels is our warming atmosphere from climate change. Sea level rise is one of 10 key indicators for a warming world, which already we can see is affecting our weather. These 10 indicators include how the temperature over land and the ocean has increased. The sea ice is decreasing. We're seeing our seasonal snow cover over land disappear, our melting glaciers and ice sheets. And I know what you're thinking, like all this ice melting in the Arctic it can't be affecting me, but researchers have been able to tie the increasing warmth in the Arctic to our changing weather patterns that we're seeing here in the Southeast. So, I mean, if we remember those two graphs that I was showing about our tidal flooding days increasing, I think we can agree that we are seeing some effects of the warming in our present day. So besides an increase in tidal flooding days, what other impacts does sea level rise have to communities? I mentioned earlier how it raises the groundwater table. So after a storm, rain doesn't drain as quickly. It can also corrode our underground infrastructure and infiltrate our septic and sewer systems. It can cause our salt marshes to migrate landward or die off entirely. And we really need our marshes because they're important aquatic nurseries for juvenile fish, shrimp, and crabs. They help protect adjacent lands from flooding. They provide scenic vistas. They enhance our property values. And honestly, they make the quality of life that much better for all of us that live here. So we really need to protect them. We can also begin to see some unelevated buildings and critical infrastructure flood more frequently. And there's associated economic effects of constantly repairing buildings that flood repeatedly or losing businesses entirely. So switching from the ocean to the sky, I want to review the water associated with our heavy rain events and how that can impact our stormwater and our river flooding. So I imagine many of us have heard this term rain bomb before. It's not a technical term, but it has been popularized by social media to describe individual thunderstorms that produce a narrow area of heavy precipitation. These events happen very quickly. They can be hard to predict and make conditions extremely dangerous to drive through. So in South Carolina, climate projections don't necessarily expect our average annual rainfall to increase substantially. They are predicting it to be somewhere between 5 to 10%. And this average, of course, is made up of plenty of variations and extremes. And it's going to be important to consider the timing of this rainfall increase that we see and how it can compound with some of the water that we're seeing from the sea. So for example, if we have a rain bomb event occur at high tide and we have rising sea levels that have pushed our groundwater up, then our water has nowhere to go, doesn't drain out as easily, it's staying somewhere for a longer period of time and causing us greater inconvenience as well for a longer period of time. What would some of this increasing heavy rain mean for our river and stormwater systems? So as Brooke kind of pointed out, for those of us that live in the North Coast, we are in the Yadkin PD River Basin, which you will see extends into a very fair portion of North Carolina. You'll also see how all these rivers start to merge together in our coastal area right before they discharge into the ocean. Of course, this is how river basins work. They're all going to converge at a point near the discharge. And it just so happens to be that they're converging in a low-lying land, which has a lot of swamps, but it also has a lot of people that live here. I'm not going to review all of the coastal river basins, but just know that they similarly can drain from very large areas, including other states, and that they're ultimately coming together in this low-lying land, again, where lots of people live, so that they can be at a single discharge point. And we've talked a little bit about the effect of the rain from Hurricane Florence. So that rain that hit North Carolina and South Carolina, how it set those water level records in our rivers. If you were, like, for example, looking in Horry County, but you would find that that was true throughout much of this Yadkin PD River Basin. So then we also need to consider if our stormwater pipes and infrastructure are sized to handle these increased rainfall events. What is going to be the cost to upgrade these systems to store more water? Or maybe we want to add a backflow preventer to keep the tide from coming up inside the storm drain. This picture that I'm showing here is a 2013 picture in North Myrtle Beach. They're putting in a larger stormwater system, and they're having a discharge pipe that goes about 1,200 feet offshore into the ocean. This is opposed to probably what is more commonly seen, those outfall pipes that are kind of emptying directly onto the beach. North Myrtle Beach has about 50 of these stormwater systems, these outfalls that they're responsible for, and they've been updating them over the years. So to kind of bring all this together, I do want to review how we have thought about some of these flooding events and how we might need to rethink some of these flooding events in the future, considering the changes that we're seeing in our climate. So typically we think of a spring tide occurring twice a month. Again, that's associated with our new moon and our full moon. We have our king tides, which is a spring tide occurring on the new moon or the full moon, but it also coincides with additional weather such as wind or atmospheric pressure changes or storms. And those are expected to occur 3 to 4 times a year. We have our major coastal flooding occurring once every 2 to 5 years. This could be from rain or it could be from hurricanes that maybe aren't impacting South Carolina directly. And then finally, we have our extreme flooding events, which are thought to occur once in a generation. So kind of here's the summary. And again, this is like what's commonly been accepted and believed of here's the occurrence of these various events and their frequencies. But what I would like to say is with everything that we've been talking about and I've been reviewing, based on the changes in our climate and our increasing tidal flooding days that we're seeing, we should expect the frequency of these events to be changing. Spring tides are, almost disappearing because now every new moon or full moon, we are having a coinciding weather event that's making, elevating these into a king tide. So now we're seeing king tides twice a month. When we look at our major coastal flooding, that could be happening 3 to 4 times a year. Again, this is because we're seeing prolonged king tide flooding events. We're having more rain bombs and we're having the slow moving hurricanes drop a lot of rain. Even if they're not hitting our ocean front directly, like in the case of Florence, they're still dropping rain and causing major coastal flooding. Then when we look at our extreme flooding events, these are the hurricanes that maybe hit South Carolina more directly. And I think if you recall, when I started off this presentation, going through the various events from 2015, how many times did I say, oh, this event was in the top 1, 2, 3, 4, 5 water levels recorded at that, that water gauge? To me, that's implying that these extreme flooding events aren't occurring once in a generation anymore. They're occurring once every 2 to 5 years. So this is kind of a lot of gloom and doom that my presentation has been focusing on. And I know we all choose to live at the coast for a reason. And let's remember, the various reasons on this slide that we choose to live here. But the most important thing we can do is to be aware of the flooding and how it's changing and make sure we know what's going on around us and how to be prepared and handle that. So I do just want to kind of end with a couple of recommendations. South Carolina Emergency Management Department has an app that you can download on your phone, and they have created this hurricane guide for South Carolina last year in 2021. But if you want to learn how to prepare for hurricanes, again, because we're in hurricane season now, it's very important to prepare early as opposed to when the skies are cloudy. So it's important to make sure you know your zone, that you're prepared to evacuate, you know where you're going, and you have a plan. This is the same app, the South Carolina Emergency Management app, just showing you another feature of it, making sure again that you know your zone and how to evacuate. So like I said, we all choose to live here. The best that we can do is to be prepared. And I know I didn't go into a lot of detail on some of the mitigative actions that are occurring in various cities and counties throughout South Carolina. But there are things that we can do to help adjust our lives to some of these more frequent flooding events, elevating our homes, preserving community green space, as I mentioned, upgrading stormwater infrastructure. So there are challenges that we can adjust to and overcome with, but we just again need to be mindful. So that is all that I have.
Thank you, Katie. We do have quite a few questions for you. So I am just going to go in the order that they've come in. So what is the risk of continuous construction compared to the change of flood elevation?
The risk of continuous construction compared to the
change of flood elevation.
I guess what I would say is the more that you're constructing, the more impervious surfaces you're adding. Again, you're preventing water from going back into the ground and draining elsewhere. So you will be increasing those base flood elevations, especially at the coast, though. I would say a lot of this is influenced by sea level rising and also just the increase of storm events. So a lot of different things can compound together to make those base flood elevations that we're seeing a lot higher.
Thank you. Can you speak to the effect of land subsidence on localized flooding?
That I don't know that I would be the best person to speak to about that. I guess it's if you're in an area that's more prone to seismic activity, or if there's a lot of groundwater withdrawal. Like I said, I don't know like a number for South Carolina of how quickly our land is subsiding or certain areas that are subsiding faster. But again, it's what is that rate in comparison to the rate of sea level rise? So unfortunately, I don't have like a number for that, but it's important to consider it in comparison with other things that are happening.
Thank you. Can you access previous or historical data regarding king tides as well as current events? And I think they're referring to the
My coast
website. Yeah.
Yeah. In terms of, you can definitely see all of the previous reports that people have submitted, and they'll always have like a graph associated with them. So they'll show, here is what the predicted tide or water level was supposed to be. Here's what it was measured as. Here's where this picture fell at the time. I think there might be a report that they publish as well. So there's definitely data out there. I would say try and explore the MyCoast website a little bit in terms of previous events. But future ones, like I said, they do kind of predict them right there on the website.
Great, thank you. And I want to refer back to the previous question on subsidence. One of our speakers, Brooke, chimed in and said we actually do not have a good number for subsidence. So
okay.
You weren't missing any numbers.
That I don't know because it doesn't exist.
Yes. Okay, where can one find all the river systems across South Carolina defined?
I think Jeff would be a good person to talk about that, our next speaker, but you should be able to easily type into your web browser of choice, South Carolina river basins, and get a very good map. I know Brooke showed one in her presentation. I just focused on, like I said, one example to kind of make a point.
I just wanted to say that the DNR, it's an older publication, but we can share it. It's the South Carolina Water Assessment. It's a second version of it. Has all of the watersheds defined and broken up by sub-basins, with hydrology and geology and demographics. It is getting a little older, but it's a really good place to start. And we can put a link to that. It's on the South Carolina DNR website.
Thank you, Brooke. Also, there's the South Carolina DHEC Watershed Atlas, which is an interactive map of the watersheds in South Carolina, so that might be helpful as well. Okay, I noticed we mentioned hurricanes. Has there been any thought to the effect and impact earthquakes might have on flooding or will have on flooding?
The only thing I would think to mention would be, I know Charleston is kind of prone to them, but apparently we don't have a very good number of if that's causing any subsidence. So that would be the only thing that I would be considering, is if, you know, your land is subsiding quickly and then compounding that with the rising sea level. But it doesn't sound like there's been a lot of research on that to date.
Thank you. And I'm at my last question, but if there is still time for questions, we have a minute or so. So if anyone has any more questions for Katie, please put them in while she's answering this next one. Okay, so this is referring to the salt marsh. And so how can we make sure our salt marsh remains healthy for as long as possible?
Yeah, I think there are a couple of innovative things that are being experimented on in other areas. One thing I know that I'm personally interested in is something called thin layer placement, where you're essentially like spraying a very thin layer of mud on existing salt marshes to kind of help them keep up with sea level rise. So keeping up, making them higher in elevation so that they're not being drowned out by the rising sea levels. So that's one thing that's innovative that's happening. I think continuing to plant salt marsh if we were seeing it disappear. But I think this is definitely an upcoming issue that we'll definitely need to be facing soon. But
thank you. And Brooke or Jeff, if you have any input on any of the questions that were asked, please feel free to chime in as well. And I'll give it 30 more seconds for any more questions to come in. And then I'll release Katie. Okay, thank you, Katie. So we are going to move on to our next speaker, and this is Jeff Dover. And Jeff is currently a senior hydrologist with the National Weather Service Southeast River Forecast Center. Started a career in 1993 in Ohio and came to the Southeast in 2003, having worked several notable floods in that span from the 97 Ohio River floods to Hurricane Florence in 2018. Served on several regional and national teams concerning floods and droughts. And today, we'll present on South Carolina river flood climatology and river forecast tools. So Jeff, if you would like to share your PowerPoint and we can get started.
Great, thank you so much. And get it set up here. Okay, can everybody see that? Okay.
Yep,
Well,
you're good to go.
Good deal. Well, thank you for inviting me to speak today. Again, my name is Jeff Dover, and I'm a senior hydrologic forecaster at the Southeast River Forecast Center. And we're going to talk about river flood climatology in the Southeast, as well as South Carolina. as well as talk about river forecasting. So our regional operational field office, the River Forecast Center, is part of the National Weather Service, and we're responsible for basically providing river stage and flow forecasts for hundreds of locations across the Southeast United States, as well as Puerto Rico. So today we're going to talk about, again, river flood climatology and river forecasting, and we'll talk a little about South Carolina as well. And so we have a number of actual forecast locations that we provide river forecasts for across many rivers in South Carolina. Most of these rivers, they actually, as Brooke and Katie have pointed out, they originate in the upstate and the mountains or the foothills, and they meander into the coastal plain. A lot of them actually originate well up into North Carolina, and that's good to make note of. Hydropower is prevalent with Duke and Dominion Power as the two bigger utilities, Santee Cooper down there in the coastal plain, and they manage the water for power. And these are all forecast location. These forecasts are all river gauges, but there are many more river gauges that are available and used. Many of these are owned and maintained by the U.S. Geological Survey, and we'll talk more about data a little bit later when we talk about river forecasting. But South Carolina, it's an interesting spot with various weather mechanisms and geography that foster heavy rain and flooding. From winter snow and the upstate high terrain to spring low pressure systems to sea breeze storms and tropical weather in the summer and the fall. South Carolina really has all the potential ingredients for flooding. And we've seen that plenty of lately. So, so how does the National Weather Service, when we talk about river flooding, how does the National Weather Service categorize river flooding? Question often asked. And so, so basically river flooding is defined by 3 impact levels, minor, moderate, and major. So the level of flooding depends on these categorical impacts. And actually the locations of where we define forecast locations are based on requests made through the emergency management because of particular impacts at those river gauge locations. So that's how actually a river forecast location comes about, is that it has impacts. So minor river flooding impacts are generally pretty minimal. It's more nuisance flooding, as it writes there. Moderate flooding is where we actually start to get some structures or some roadways impacted, some common roadways impacted. And then major flooding, we see more of your widespread impacts and inundation. These major floods, they're typically on the order of, they usually come every 10 to 25 years in most locations, if not greater intervals. So how often do we see river flooding and when is it most common? Well, here's the river flood climatology for the Southeast US, looking at 101 different forecast locations. And we see that even though the tropical season can pose a threat for a more significant rainfall and flooding, the primary river flood season for the Southeast is during the winter and into early spring. This is the primary sort of recharge period, and it's roughly that December through early April period. And South Carolina, when we look at just South Carolina, that river flood climatology looks pretty close to the same, similar to the Southeast as a whole. December through March being the most active, with a secondary season again during that late summer and early fall period. The flood season tends to cut off, pretty quickly in April as vegetation begins to green out and that rainfall switches from those late winter large rain systems to that more scattered thunderstorm activity. And for the most part, most of the Southeast, the interior Southeast, that's the way it looks. You see is, the primary recharge period or the primary flood season is during the primary recharge period. And that's that winter through early spring. The only exception in the Southeast that doesn't follow this rule is actually the Florida Peninsula. So when we look at when damaging river flood events are most likely, we see March is a big month, but February, March, and April make up most of the flood season. September is also an important month with tropical storms. And then that little chart down at the bottom left shows the return periods of tropical storms by month for the Southeast. And we see September, the Southeast pretty much sees a tropical storm every year on average. And for South Carolina, tropical systems have not been shy lately. So yeah, September, August, you can see 1.2 year return period, September 0.9. So August, September, we see about a storm in the Southeast every year. So again, as Katie talked about several of these storms, tropical systems have not been, have been pretty common of late. Katie talked about Joaquin, or Brooke, I think, mentioned Joaquin as well. When we, that was back in October 2015, and we'll remember when that Hurricane Joaquin had sort of sat off the coast. Wasn't actually a direct effect of Joaquin, but it sort of sat off the coast and sort of produced that fire hose of moisture and heavy rainfall in the South Carolina, creating that major flooding. And then, we had Matthew a year later in October of 2016. And notice how, we get a lot of these floods in North Carolina. A lot of times those end up making, that water makes its way down into South Carolina, as I believe Katie and Brooke brought up the point about the Yadkin River making its way down into the PD. And this is also holds true with the Waccamaw River. And so in 2017, we had Irma, which mainly hit Florida, but it did skim across South Carolina there with some heavy rain and flooding. And then in 2018, I think most of the forecasters at our regional river center, we thought Joaquin was going to be one of our career storms, and that we probably wouldn't see river levels like that on some of our rivers, especially the Waccamaw, again in our career. Little did we know in 2018 we would see it again and even higher when we had Florence, which again brought major flooding to the same rivers. Again, the Waccamaw, the lower PD, and river that just has seen really flooding with several events in the past several years. So that was pretty significant, and two big events in the matter of a few years is pretty wild. Then a month later we had Michael. So lots of memorable floods recently, and thankfully we've been a little bit quieter, but it has been pretty active. So let's switch gears a little here as we talk about river flood seasons and the past events. Now let's talk about river flood forecasting. We showed where our river forecast points are, but how do we produce an actual river forecast that you guys may be familiar with? You all may have seen the image there that goes out 5 days, but how is that made? And as you can imagine, of course, lots of data. We have to know where and when the water is coming from the sky to the ground, to the rivers, and from the past to the present. This data gives us a starting point to forecast into the future. So the big three that we usually like to say are rainfall, river observations, and reservoir data when it comes to river forecasting. So rainfall, as far as what we use for our river modeling to predict these river stage forecasts. Rainfall, we don't just use rain gauges. We use more than just rain gauges. We're using, using just rain gauge that rain gauge, it doesn't give you that needed spatial identity for hydrologic forecasting. So we use a radar gauge field. That radar field is biased by the rainfall gauges. So the more rain gauges, the better the overall field is typically. And that's been a big improvement over the last as far as river modeling over the last 15 years. 15 years ago, we were just using gauge rain data and just didn't give us that spatial identity. So that's why rain gauges are so important, not only to flooding, but also to drought. Then there's future precipitation that is used in our forecast models. River forecasts, this is a very important to note. Our river forecasts that are our official river forecasts that you see, those only use out through 2 days, only out through 48 hours into the future do we use river forecast or rainfall data in our river forecasts. And the forecast is typically, that rainfall forecast is typically very close to the national WPC standard that you all may be familiar with. So what else do we need? Well, of course, river observations. There is really no way to forecast river effectively without river observations. So, we always see the famous saying, we can't forecast the future if we don't know where we are today. And that's why we need river observations to initialize our hydrologic forecast model. And we need observations that have a flow to stage relationship. That's a very important concept. Stage only observations, they're really not optimum and aren't going to work when we are using our hydrologic model that is basically converting runoff to flow and routing water from one river location to another. And here's where I put my plug in for the USGS gauges. We work very closely with the US Geological Survey. During floods, we talk closely with the South Carolina USGS group. When we need measurements during big floods, flow measurements, they go out and make those measurements to help with our critical forecasts, and they're always there to help. So they're a big part of the forecast process. They keep the ratings, those stage to flow relationship ratings up to date, and they're also maintaining those gauges. So US Geological Survey, very important to river forecast process. And finally, the third of the 3 R's, rainfall, river data, and reservoir. We have reservoirs. The Southeast and South Carolina are filled with private power reservoir operators to produce many of the forecasts we are asked to produce. Of course, we need those reservoir operators to provide us with data. Many have tailwater gauges that tell us what they're releasing. Some tell us and send the data, and some even tell us what they're planning or their future releases if they can. So we really at the Southeast River Forecast Center and at the local weather forecast offices have and try to keep these key relationships when we're operating during a flood. We're actively coordinating with these private and public utilities, U.S. Army Corps of Engineers. We're actively coordinating with them during our flood events. And in South Carolina, the private power reservoirs, as well as public, of course, the U.S. Army Corps of Engineers, but the private entities are even more prevalent. That would be Duke Power, Dominion Power, and Santee Cooper. We often call them and ask them what they plan to release. And in turn, we're also sharing our data on what kind of inflows would be coming into their projects. So we a lot of times want to be on the same page as far as public message with these companies. So again, we talked about our 5-day river forecast that uses expected precipitation within the next couple of days. But what about seeing what rainfall may do beyond that 2-day period for our rivers? That potential hurricane that could hit 4 days out that is saying potential flooding, or that heavy rain expected that may come on a weekend, but the river forecast does not show a rise because it is a Wednesday and it's too early to see the forecast. So now we're using what we call ensemble or probabilistic forecasts for those periods. These are 2 outlook forecasts that are available or will be available online. That's the MMEFS and the HEFS probabilistic river forecast. They both go out 10 days and they show a range of possibilities based on uncertainty in the expected precipitation. So, you may ask, where can I find all these forecasts? Well, you can find them on water.weather.gov. Most of you may be familiar with this page. And if you are familiar with the page, note that the look and feel of this page is going to be changing toward the end of the year. Most of you were probably familiar with the acronym AHPS or AHAP service, the Advanced Hydrologic Prediction Service. That's where all the forecasts are. This will, by the end of the year, will be changing over to the National Water Prediction Service, which will include an array of different water forecasts, as you see currently, as well as some new services potentially from the National Water Model. Another question we get in South Carolina is, what about tidal forecasts? I think Brooke and Katie were talking about these earlier. Well, we talked about the 4 we have in South Carolina. These use the tides and potential surge, but do not include a freshwater influence. We have 4 tidal forecasts on the South Carolina coast, and these are best used during, not during tropical systems. If there's a tropical system or hurricane, it's best to use the surge information from the National Hurricane Center. And what about tidally influenced river forecasts in South Carolina? Well, we actually have one forecast point. That's the Waccamaw River at Conway, where we actually use a hydraulic model to do the water balance between the fresh water coming down and the potential surge. This is one of just a handful of hydrologic river forecasts that we produce at the Southeast River Forecast Center. And this one in particular performed very well during Florence in 2018. So as far as inundation maps, this is always a hot topic for most people in water and water forecasting. We do have a static inundation map that has been available for quite some time on the Saluda River at Greenville, South Carolina. But the National Water Model will be really the tool for the future that will make flood inundation maps more available. And actually, this is a priority goal for the National Weather Service. And we're hoping to have maps for the entire country by 2027. And those will be out of the National Water Model. And finally, one question that we often get is, how accurate are our river forecasts? Well, really that's not an easy answer, because it really does depend on the river and the river forecast location. Future rainfall is still one of the hardest inputs in the forecast to get in there and get correct. But the good thing is the forecasts have gotten significantly better in the last 10 years and will continue to get better in the next 10 years as the science and the computing power evolves an array of advanced decision support tools. So that is, I know, quite a number of topics we talked about, and I want to thank you for letting me talk today. And that's all I had. If you have any questions, you can always email me, but I can take some questions now.
Thank you, Jeff. We are a little over time, but I'm going to try and get through all these questions. If you do have questions for Jeff or any of the other speakers, please put them in the chat or in the Q&A box, and we will try to get to all of them. Okay, for the Waccamaw River, is there any data that shows a connection to sea level rise, to more flooding, or is it just due to the hurricanes passing by our coast?
Really, and we get this question often. I would probably say, from my expertise, I think it's been because of the significant rainfall issues that we've had, the significant tropical systems that we've had. It's more the rainfall that's not only fallen across the Waccamaw watershed, but in South Carolina, but in the upstate as well, in North Carolina. Whenever you get in excess of a foot of rain in some of these storms, you're going to be, you're going to be treading into that major flood level.
Thank you. Has size of flood in response to given rain events increased, perhaps as a result of increased pervious land percentage and draining of wetlands?
I haven't really seen any research along those lines. Again, this is probably going back to, of course, flooding, as Katie and Brooke point out, there's a lot of factors, right, in terms of flooding. I would say the biggest factor is the rainfall amounts, but of course, impervious surface does play a role in the amount of runoff. And as we all know, the parts of the low country of South Carolina, Myrtle Beach area, up and through North Carolina, as we all know, it has grown significantly in terms of population and growth, suburban growth in that area. And of course, that does probably affect the runoff into the rivers. But with that being said, these significant rainfall events, I think, are the biggest contributor.
Thank you. This next one is related to flooding forecasting. How much does flooding forecasting take into account rainfall in recent past, stream stage level, and watershed land use land cover? Do you adjust according to previous behavior of the particular river?
Yeah, that's a good question. So we run a runoff model, a real-time hydrologic model, and within that model, we run a runoff model, and it's a lump basin model that uses the Sacramento soil moisture accounting model, runoff model. And it's a conceptual model. It's not based on any physical properties of the soil. It's more of it's a conceptual model that uses historical rainfall data to basically calibrate in the past to perform into the future. So it's not really a physical based model. It's a conceptual model where we try to emulate how wet or dry the soil is. And that gives us our rainfall to runoff conversion. Now, with that being said, the Weather Service is exploring into physical based models, and the National Water Model has a physical basis to it. The underlying grids and the underlying distributed model will have a physical basis to it. So currently in our office, no, not really, but in the future, we will have more physical based models.
Thank you.
Hopefully that answered the question.
This is in regards to reservoirs. What requirements are in place for reservoir partners to notify downstream communities?
The public utility, of course, the Corps of Engineer, and they're not really utility, but the Corps of Engineers is a little bit different than the private reservoir operators, private utilities. There's not, to my knowledge, there's no requirement that they cooperate with us, but they know as well as us when there's mixed messages out there about how water is being used or being more or less operated, or it's the word I'm looking for, planned down the river, routed down the river. We have to be in concert with each other. We don't want to have mixed messages. Now, the Corps, they're a federal agency. They have to work closely with us. Duke and Dominion and Santee Cooper, I don't think there's any requirement other than what's in their FERC requirements. But during flood events, of course, they know it's important to work with us to keep the message clear. And it's helpful to them because we give them an idea of how much water could potentially come into the reservoir. And then they give us an idea of that's the word I was looking for, how they will manage that water as far as releases go, which is important to our downstream forecasts.
Thank you. We are at time, but maybe you can answer this question very quickly. Is the South Carolina water assessment going to be updated to account for climate change? And I think that might go to Brooke.
I don't know. I don't know if we're going to do another version of that assessment, or it's kind of been parsed out in different methodologies or in different formats, because now we have web apps and maps that we use, and so I don't know if we will put together another large document like that, but we can definitely talk about it.
Thank you. So there's two questions regarding reservoir that we're not going to get to, but Jeff, if you want to, while we're doing the conclusion, if you want to go onto the Q&A, you can type answers if you know them. And we'll go ahead and release you. So if you can stop sharing, and thank you so much for your presentation and all of the information. I'm going to turn over to Emmy now to bring us home.
Perfect. Okay. Thank you so much. So just to quickly wrap up our session today, thank you so much to our speakers, to Jeff, Katie, and Brooke for their wonderful presentations and sharing their expertise with us today. We want to remind you that our next session is this coming Tuesday at 1:30, and that is Who's Who for Flood Management and Recovery. So we hope to see you all there. And we'll also be putting a survey follow-up in the chat shortly. So if you will please fill that out on your way out. And we, again, thank you so much for joining us today.
Thank you, Emmy. And for those of you who asked the questions that Jeff is, he's currently typing answers. So if you want to hang on the line, he'll get an answer to you. And thank you for joining us.